For the period of 2014 to 2016, there was a marine heat wave called the blob in the northern Pacific Ocean. It affected a lot of things, and it didn't help that there was an El Niño year during that time, or an El Niño cycle during that time. We haven't really quantified the effects that it had on species really until now. Studies are starting to come out saying that species such as the murre, a seabird, a very common seabird in Alaska, have had about a half of their population die off. That's over 4 million individuals die off, not just because of the heat wave, but because of the effects after the heat wave, which makes it even scarier and why we should be really worried about the effects of climate change. We're going to talk about that on today's episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Luan. This is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And I have to, again, apologize for my voice. This cold does not seem to be going away. It's affecting everything I do, but especially when I talk, and now I'm really congested. So I just wanted to apologize for that. Anyway, this is the podcast where you find out everything about the ocean. So if you want to know more about the ocean, you want to know how you can protect the ocean, not only do you want to listen to this podcast, but you want to go over to our website, speakupforblue.com. That's speakupforblue.com. You get information, episodes of our podcast, video podcasts, other podcasts that we have out there, as well as just information on the ocean in general and how to protect it. You can also get that information to your inbox if you don't want to go just directly to our site. You can just sign up with your email for free at www.speakupforblue.com/newsletter. That's www.speakupforblue.com/newsletter. Now, I mentioned I have a cold and something that's helping me get through my cold over the last few days, especially as I get closer and closer to the holidays, and I want to have a good holidays. I don't want to be sick over the holidays. So my big thing is sleep, nutrition, and also my Magic Mind. Magic Mind is something that I've been using especially over the last year or so. It's been allowing me to get my dosage of just like ginger, just good like matcha, like just good doses of good food and ingredients into my body to allow me to function not only during the day, but just to keep a healthy body. I've seen a lot of people with pneumonia, with like all these different types of viruses going around, and it's causing them to disrupt their day-to-day activity. This is allowing me to fight off a common cold. Hopefully it doesn't get any worse, and it allows me to say, hey, you know what? I feel better about myself. I know I'm putting healthy things in my body, and that helps a lot. Now, this is obviously not a cure for any kind of virus, but it helps me keep fighting off everything and keeps my immune system up. So I like to thank Magic Mind for that. So if you want information on Magic Mind and you want to buy Magic Mind, you can use my link, my affiliate link. If you go to www.magicmind.com/Lewin20, that's LEWIN 20. That's magicmind.com/Lewin20. Check it out. Love to hear what you think about it. Just hit me up on How to Protect the Ocean Instagram. Just DM me. Love to hear your thoughts on that. Anyway, let's get into the episode. This is a really interesting, I'm not a seabird expert by any means, but they've always interested me in their patterns and their trends. Obviously, they really tell a story about how healthy the ocean is and how plentiful the food is in the ocean when you have a healthy population of seabirds around. And in Alaska, on the Pacific Ocean side, Murres, pronounced Murres, it's spelled M-U-R-R-E-S. It's a common seabird, and they look a little bit like flying penguins. Their stout, tuxedo-styled bodies dive and swim in the ocean and eat small fish, and then fly back to the islands or coastal cliffs where they nest in large colonies. But their hardy physiques disguise how vulnerable these birds are to changing ocean conditions. They rely on food from the ocean, so any disruption of the ocean and the food supply will disrupt this population. This population, healthy-wise, back in 2008, this population in a healthy state is about 8 million individuals back in 2008 when measured. This species has been monitored from 2008 to 2020, and some studies have come out to say, hey, you know what? The species isn't doing very well. The health of the population is actually cut into half, and there's a number of variables around that, and obviously there's some day-to-day things. Like in a regular situation, there are disruptions in the environment. There are disruptions to populations. Population can undergo small die-offs. A population can undergo changes in just like short-term disruptions, right? If something was displaced in their colony or where they go on their cliffs or in their islands, maybe that would affect their young of year for that year, or their reproductive group for that year, the babies essentially. And then there's other times where, you know, maybe the food supply moved over a little bit and it came back the next year. So that year that they moved over, maybe the population didn't do so well. There's a lot of different things that could happen, right? We just don't know. Sometimes diseases break out in a colony, and that colony can lose some individuals. It could lose hundreds, it could lose thousands, it could lose 1 million or so. But the ability for that healthy population to bounce back is really what we look for in healthy populations. We have small die-offs all the time, and then if their ability to come back to the right number of individuals, or come back to even more, or just a little bit less, shows the recovery of where we're at. We monitor it just like we monitor fish. But not a lot of people eat seabirds, and that's okay, but we monitor their population on the ability to recover, ability to buffer a system as it changes through time. But over the periods of 2014 and 2016, we saw the heat wave, the blob. And this was a heat wave that was combined with a couple of El Niño years, made everything super, super warm on the sea surface temperature, and it just changed a lot of things. Some things we just don't even know how much it changed yet, and we're just getting a little bit of an idea. So in 2020, the University of Washington-led Coastal Observation and Seabird team, also known as COAST, which is a great acronym, by the way. Scientists put up a lot of acronyms, but this was really good. It was COAST, C-O-A-S-S-T. Very good acronym. It makes sense. Everything's looking on the coast. You're doing Coastal Observation and Seabird Survey Team. Very good. The observers first identified the massive mortality event affecting common murres along the west coast of Alaska. The study documented 62,000 carcasses, mostly in Alaska, in 1 year. In some places, beachings were more than 1,000 times the normal rates, but the 2020 study did not estimate the total size of the die-off after the 2014 to 2016 blob event, right? That was one of the big things. Now, this was a citizen science program that the University of Washington had led, and so which is basically the coastal residents searched at local beaches to find dead birds and documented those dead birds, which contributed to this new study. And it was led by federal scientists from the U.S. Fisheries and Wildlife, which was kind of interesting. So the one that was published December 12th, just recently in Science, a team led by the U.S. Fisheries and Wildlife Service analyzed years of colony-based surveys to estimate total mortality and later impacts. So the analysis of 13 colonies surveyed between 2008 and 2022 finds that the colony size of the Gulf of Alaska east of the Alaska Peninsula dropped by half after the marine heat wave. In colonies along the eastern Bering Sea, west of the peninsula, the decline was even steeper at 75% loss. So it was led by Heather Renner, a wildlife biologist at the U.S. Fisheries and Wildlife Service, estimates that 4 million Alaska common murres died in total, about half of the total population, and no recovery has yet to be seen. The study shows clear and surprisingly long-lasting impacts of a marine heat wave on top of marine predator species. This is said by Julia Parrish, a University of Washington professor of aquatic and fishery sciences and of biology, who was the co-author of the paper, the 2020 paper, and the new study. Importantly, she goes on, the effect of the heat wave wasn't via thermal stress on the birds, but rather shifts in the food web. That's in the food web, leaving murres suddenly and fatally without enough food. Here's the problem. A lot of the times, as I mentioned, usually the short-term disruptions actually affects the mortality of the birds. This mortality will be short term, so it means that the species will be able to recover, the population will be able to recover because it's not that much of an effect. But the problem is this heat wave has affected the food source, inevitably starving these species, right? These individuals or this population to the point where they lose half of their population. There's no recovery yet because the food within the ocean hasn't recovered yet. When we start to see animals either shifting areas because it's too hot, right, and these birds haven't been able to find where they're going, where this new population is, or the population that they're feeding on, the prey, have actually just died off because it's too hot. Animals within the ocean have a certain range of heat tolerance. There are reasons why certain species are where they are. Cold water species are in the cold because they require ranges in the cold. If it gets too hot, their bodies can't handle it. And so they either have to move to colder areas where it's more comfortable, or they end up dying off. That will affect the predator-prey relationship of these Murres seabirds. When the Murres can't find enough food, their population will die off. They will not recover until that population goes up. And we have seen this in a lot of predator-prey relationships. We've seen that in a great analogy would be the sea otter, the kelp, as well as the sea urchins in the Pacific Ocean. With a lot of sea otters around, they keep the urchins intact. And without those sea otters, we'll see an increase in the predation of sea urchins on kelp, and we'll see a decrease in kelp habitats, right? We also see it a little bit from sea stars when we start to see sea stars eat kelp habitats as well. This all fluctuates as each of these populations of species fluctuate. So once we start to see a reintroduction of sea otters, then the sea urchins go down a little bit and the kelp kind of come up. Of course, the abundance of the sea stars also affect the recovery of the kelp forest as well. So it all just teeter-totters based on the abundance of each of these populations of different species, and it can get quite complex. But when an overall shift in the temperature of the ocean will change the actual prey relationship, right? The predator-prey relationship with losing the abundance of a specific prey, and there is no other prey to take that place, then you're going to start to see a loss with the seabird population, just as we're seeing, by half, and no recovery in place, right? We haven't seen anything that's been observed. If you don't remember, the warm blob was an unusually warm and long-lasting patch of surface water in the Northeast Pacific from 2014 to 2016, affecting weather and coastal marine ecosystems from California all the way to Alaska. As ocean productivity decreased, the effective food supply on top predators, including seabirds, marine mammals, and commercially important fish, also changed. Based on the condition of the Murres carcasses, authors of the 2020 study concluded that the most likely cause of this mass mortality event was starvation. So there it is. They starved to death. Unfortunately, most of them starved to death. Obviously, this is a problem for this population. How this will affect the rest of the food web, we don't know. There's still a lot of research that needs to be done. But it appears that an event as significant as the blob for these 2 years have affected the populations of a top predator within this food system, which is telling of how the food web within the ocean has changed. And we don't even know those effects yet. There's going to be more research that needs to be done to be able to see what those effects are on this food web and what those changes are. But we may have actually passed a tipping point in our ecosystem management. And we have like where recovery for some of the pre-die-off abundance is not possible. Just think about that. We may be at this tipping point for this species and many others where we may not be able to have them recover. They may just be down at 4 million and maybe even lower in the future, because if their prey hasn't recovered, their prey population hasn't recovered, they're not going to recover. More and more individuals are going to die until they can actually have enough prey to sustain that population, right? That number, that population. And we don't know what that number is. So obviously they need to do more research on what that prey population is and where it's at from its population, how that's changed, has it moved over, who knows? We don't know how it's going to recover, but obviously monitoring and research needs to be done. And this is why it's so important to fund research. This is why it's so important to be at a point where we can ensure that governments, as well as nonprofit organizations and institutes and foundations, are funding this type of research, because we need to know how these changes are affecting populations around the world, from top predators to the bottom of the food web and everything in between. So that's it for today's episode. I wanted to just thank you for listening. And if you have any more questions or comments, please feel free to put them the comments down below in the YouTube channel. You can also put them on Spotify. They allow you to actually comment. I would be more than happy to answer any kind of comments. I'm trying to look out for them as much as possible. And of course, if you want to follow or subscribe to us on any of the Apple or Spotify or any of your favorite podcast app, please do so. We're available in video and audio on most platforms. With me, you can do so by hitting me up on Instagram at How to Protect the Ocean. That's at How to Protect the Ocean on Instagram. DM me. I'd be more than happy to have a chat with you. And I want to thank you so much for joining me on today's episode of the How to Protect the Ocean podcast. Have a great day. We'll talk to you next time, and happy conservation.